Right, now we're going to be looking at a challenge and a real-world connection problem relating to parallel and perpendicular lines. I encourage you to give these a try on your own, and then pause the video and then check back in and see how you did as you follow along. So our first problem is the vertices of a triangle are at those following points. So we have 3 different points on a graph, and we're curious. We're wondering, is the triangle a right triangle? So one quick way to do it, which we're not going to do, but a quick way would be to plot these points up on Desmos and just see if it looks like a right triangle. But even if it looks like a right triangle, we might want to be extra confident that it is a right triangle. So this problem basically turns into finding a bunch of slopes and seeing if any of the slopes are negative reciprocals of each other. Okay, so let's see here. I'm going to give us a little space to work with in the problem statement. Let's do something like this. And let's call this point A, this point B, and that point C. Okay, so we're going to find potentially 3 different slopes. We might get lucky, and the first 2 slopes might end up being perpendicular or negative reciprocals of each other, and then we can end. But we'll probably need to find all 3 slopes. So let's find AB first. And then, so this problem really becomes, I think the challenge becomes staying organized and making sure you're keeping track of the slopes for the different combinations of points. So slope is the difference of the y values divided by the difference of the x values. Negative 4 minus 6 is negative 10, and 1 minus 5 is negative 4. So this turns into 2.5. I'm going to keep it as a fraction, 5 halves. Okay. So if we get a future slope that is negative 2/5, I think we have a right triangle that we're dealing with. But let's see, BC. So we have the difference of the y values divided by the difference of the x values. That's going to be a 3/7. So no perpendicularity yet. We don't have any negative reciprocals showing up yet. And then AC, the difference of the y values over the difference of the x values. Negative 7, 1 minus a negative 2 is 3. Aha, look what we got. So these 2 are perpendicular. We have a 3/7 and we have a negative 7/3, and our symbol for perpendicularity is that upside down capital T. So is the triangle a right triangle? Yes, it is. Okay, next one. In a graphics program on your computer, you're sketching a design for an advertisement. The computer uses a coordinate system that makes it easier for you to plot your points. You have a line drawn already that goes through the points 1, 4, and negative 2, 5. I'm going to draw a rough sketch here. Not necessarily perfectly to scale, but let's see. 1, 4, 1, something like that, and negative 2, 5, something like that. So it looks like we have a line that's going something roughly like that. You want to create a perpendicular line, let's see, through the point 1, 4. So it looks like we want to find this line, and then we want a second point. We want to find some random other point on the line that we could ensure and it gives us a perpendicular line. Okay, so we're looking for like a different point on that red line. Okay, cool. We got that problem statement figured out. So let's find the slope of the black line first, of our given line first. So slope, like we've been doing, it seems like forever, is the difference in the y's divided by the difference in the x's. 4 minus 5 is negative 1. 1 plus 2 is 3. So we have a slope of negative 1/3, which agrees with our drawing that we did. And so we want our new slope to be a positive 3. Positive 3 over 1. Okay, and we want it to go through this point with this slope. Okay, cool. So let's, might as well just do a point slope form equation. Let's get an equation written out. Y minus 4 equals 3 times x minus 1. So there's the equation of our new red line. And then we can just pick any random x point. Let's pick x as 10, okay? Actually, let's pick x is negative 2-ish, so we'll get a point somewhere down in there about where that point is that I was suggesting we might get. So let's pick x is negative 2. Okay, it doesn't really matter. We just need another point to connect. So we have y minus 4 equals 3 times negative 2 minus 1 is negative 3. So y minus 4 is negative 9. Let's add 4 to both sides. So y equals negative 5, right? And I paused for a little bit because that's pretty far off, and what my point looked like. It looked like we were going to get a positive y value. So let's try to figure out why that is. I want to do things a little more careful to check. So it looks like my new point, it looks like my answer is going to be negative 2 comma negative 5. But let's do a more careful graph right here and check. Okay, because that first graph I did was a little bit of just a sketch graph. Okay, so my initial equation went through 1, 4, 1, 2, 3, 4, and negative 2, 5, 1, 2, 3, 4, 5. And we have a line that we can draw. And we want my new perpendicular line to go through here. Let's make this guy red. Does that look perpendicular? It looks relatively perpendicular. So you can see how just having a slightly incorrectly sloped line, and I think you can see my initial red line was a little bit off of perpendicular. You can see how much that changes things. So it looks like our new point, according to the algebra we did, was negative 2, 5. 1, 2, 3, 4, 5. So again, we're a little bit off. We didn't graph it perfectly, but on the note-taking app I'm doing, it's challenging to draw a nice perpendicular line. But I think we can see that the graph is supporting our final answer. So evidence that we should do a more careful graph next time. So anyway, there is our answer. Our new point is going to be negative 2, negative 5. And that's a good place to stop.